Hello and welcome. My name is Andre and I'm excited to have you guys here. Looking forward to teaching this course for time series forecasting in Power BI. The first question is, how do you find this course? Well, you probably found this course by Googling time series forecasting, or you may have found our video on our YouTube channel. But there's two ways to do this. If you first found it from YouTube, then you could go to the description of this video, and then there will be a link there where you can get to the course itself. So you could download all of the lab materials, because this is not just a theory. This is actually a hands-on course, so you get to practice everything here. And at the end of the course, you'll be building beautiful visualizations that are doing time series analysis, and you're not going to be using any crazy R, any crazy Python. You don't need to have any data science skills. Just using plain old DAX, plain old Power BI, you will be able to implement time series analysis. Or you can also go to obviEnce.com. So you could go to obviEnce, go to courses in lab, and go to time series forecasting, and you can find that course there. Again, this is a hands-on course. You could just flip through all the lessons and complete all of the steps necessary to get up to speed on this super amazing and super useful calculation. The next question is, who is this class for? Well, this is a level 200 course, which is a good news and a bad news. If you have zero knowledge of DAX, you might find some of the material covered in this course a little bit challenging, but it's also not a level 300 course, which means you don't have to be a data scientist. If you have some foundation of DAX, you have done things like calculations and a little bit more advanced things in DAX, you should have all the skills necessary to get through this. Also, some understanding of the problem domain, some understanding of basic analytical skills is also helpful. However, we are not expecting for you to be super savvy and super technical. Why would you want to take this course? Well, the most important, obviously, because you want to master predictive analytics. And you also want to enhance your skill set. So this is a hands-on course. You get to practice, and you're guaranteed to actually learn something from the time that you invested in going through it. Quick course overview. The course is based on just 6 quick lessons. Most of them are really quick, maybe just a couple of minutes, and some of them are a little bit longer. So for example, the lesson 2 and 3 probably will take bulk of the time, but the rest of the course are very quickly, and you can breeze through them probably in under an hour or two. Let's jump in. What is time series data? Well, time series data is just a sequence of data points that is collected or recorded at a predetermined interval. So those intervals have to be specific, whether it's daily or weekly or monthly or quarterly, sometimes on an annual basis. Some data gets collected and recorded, and then we are looking for patterns and insights so that we can make some forward-looking statements or create a forecast. Example of this might be stock prices. In our case, we'll be looking at monthly sales numbers, or you could look at things like temperature. Basically, no matter where you look, if you're in enterprise world, time series data is literally everywhere. Let's take a look at our example. Here, we're looking at a Power BI chart, and in a blue line, we see a distribution of our data. We have a line running through this, which is the trend. And then here we have a dotted line, which is something that we'll be creating in our lab, in our course. This is our forecast. Now, Power BI has a built-in features to generate a trend, and it has a built-in feature to generate a forecast. However, a lot of times you want to be able to be in control for how the trend is plotted and how the forecast is plotted. And you also want to be able to understand what is the logic behind these lines. So you don't have to rely on Power BI. You don't have to rely on numbers that you cannot explain how they were arrived at. And time series analysis is all about looking for data. So here we see a upward trend, and we also see some seasonality. So for example, it looks like peaks and valleys come at predetermined times. That could be based on business cyclical data, on weather, time of the year, holidays, and so forth. So the idea is, can we find these patterns in our data set? And then if we do find those patterns, can we get reliable predictions to infer what might happen in future? So a little bit of theory. As we said before, our time series analysis typically is broken into two components. In our case, we're doing level 200, not a particularly sophisticated approach. We're going to be doing a two-prong approach. First, we're going to calculate the trend. And all the trend is just a line that fits through all of our actuals, and that allows us to kind of figure out what might be happening with our business in future. So is the business growing overall, shrinking overall? So it's very important to understand what our trend is, and we'll talk more about it as we go through our exercises. On top of that, we need to calculate seasonality. This is the seasonality from our data set. So you can kind of see that it's very similar year over year. So if I'm trying to calculate what my forecast might be, all I need to do is figure out how I can plot the seasonality, figure out how I can plot the trend, add one to another, and voila, I'm going to have my time series forecast. Now, we're not going to get into more advanced topics for time series forecasting, such as cyclicality. We're not going to talk about randomness too much. So there is a lot of stuff that's happening in this world if you are very sophisticated. For level 200, it's good to be aware of those concepts, but we're not going to spend too much time on those. Also, there are some super well-established best practices for time series analysis. Again, it's good to know about them. For our level, we're just going to focus on two. We always want to make sure that there's no missing data in our time increments. So if we're looking at data weekly, we need to make sure that all of the weeks have some data points. And also we need to have a strategy to validate our model. You never want to just come up with some numbers and not having done your homework to make sure that if you recast it, for example, if you have 3 years worth of data and you come up with some sort of pattern that you feel is looking good, maybe you want to apply that analysis on the last year of your actuals just to see if it's predicting the last year well enough so you could trust the forecast that it'll generate for the future. Our data set is also very simple. We have just two tables. Here we have our sales table. I took out a typical attributes that you would have here like product or customer. So we're just focusing on things that are super important. So we have to have our date. So in our case, the grain is weekly. We will be looking at weekly seasonality, and we're just trying to forecast our revenue. Now, you can easily add additional lenses to this. Nothing in the calculation will change dramatically, but I'm just trying to make it simple for everyone. Also, we have a date table. The date table is required only because we're going to be using some date functions in Power BI, and those do require us to have a date table. The other thing that's important, in our date table, for our approach, we need to have a week number or week attribute so that it allows me to compare the same week year over year for my seasonality calculation. So basically the required fields in my date dimension here is week start date and also the week number. And year obviously will be very helpful. So nothing here, nothing in date dimension you're going to find super crazy. Most likely you already use a date dimension that looks very similar in your day-to-day job. And now we're about to jump in and actually start working on building the trend measure. Before we start coding, let's get set up. So our lab comes with two models. So here in the Let's Get Up section of the lesson 2, there's two buttons. The first one says download the lab, and that will give you the initial file. That file is very simple. It just has the revenue measure. It already has all of the data populated and ready to go, so you don't have to do any data massaging. All you need to do is just focus on the actual calculations. So we have our sales file, we have our date dimension, and we have our revenue. We also have pre-created some charts for you. So the first one is the default Power BI chart. That is using default Power BI features like a trend line or forecast. So here's the trend line that it generates, and then this is the forecast that it generates. Again, the challenge is it works very well for this chart, but I cannot explain to you what formula is used to create this trend line and what logic is used to create seasonality. Also, none of these numbers I can use downstream for any additional calculations. So we want to have control over how these lines are created, and that's why we're doing this entire lab. Now, once those two calculations are done, you could plot them on these two charts. The first one is the one that will help you create a trend chart, and we also will be using this chart to test. And the second chart is used to show our forecast. So when you're done, so again, this is the download the lab 1. If you download the final model, and let's take a look at what that looks like. That final model has all of the calculations that we need. So these are all of the calculations that we're creating. And it also has all of the visualizations done. So here we have our trend line running through the revenue chart. And then here we have our forecast. But you could see that this trend line actually comes from a sales forecast trend measure. And this final forecast comes from a sales actualized forecasted revenue measure. So if you get stuck going through the lab, or if you just want to test the final result, go ahead and flip over between the two models so you can compare and contrast and get through the lab. So now at the end of this chart, of this lesson, we have the actual calculation for the sales forecast trend. As you can see, it's pretty intense, but don't be despaired. What I will do next is go through every step of this calculation so that you're more than comfortable using it in your own models. To do that, I will open up my final lab, so the final output, and let's take a look at the sales forecast trend measure. So this is this measure. Let me make the font a little bit bigger so it's easier for you guys to read. As you can see, it's pretty involved. So what we will do is we will walk through logic one line at a time, and in the next 5 minutes you guys will become an expert in this logic. It's actually pretty simple. I know that it looks a little bit involved and sophisticated, but it's actually not that complicated. So if you understand table functions in DAX, you should be able to get through this pretty easy. So let's take a look at our code here. So what are we actually trying to do? So we're trying to create a trend. What does that mean? That means is we need to have a table of all of these actual values. And once we have all of this table, we need to run a line through this. So a line is created using a normal function. Y is equal to slope times x plus intercept. So first we need to figure out what will be our x and what will be our y, right? And then once we figure that out, then we need to calculate what our slope will be and what would our intercept will be. So in this chart, I actually have a week start date as our x. However, in order to do the math correctly, we need to replace the actual date with an index. So we want to start at number 1, 2, 3, 4, 5, and then for every week after the start of our actuals, we want to just have the week represented with a sequential number. So once we have the sequential number, that number will be our x. It will not be the date, it will be the sequential number of the week, the sequential representation of the week. And then that number times the slope will actually allow us to create this line. So let's go through this logic and see how we do this. So basically the step one is we just need to create a table for all of the actuals. And the way we do that is, in order to create that table, what we need to do is, and these measures will become important, so it's good to just have them pre-calculated so we can use them downstream. So first thing is we're going to create actual start date. And the way we do this is we're going to create a table of all of the dates, then we're going to add revenue to it, and we're going to filter out those rows where revenue is not there yet. So now we have a table of all of the dates with actuals, and then we're using minX function to figure out what the start period is. And we're going to use a very similar logic to get all the dates, add revenue to them, filter out the blanks to find the max. So now when I have actual start date and end date, I know where my range starts. So, and how do I test it? I can, for example, take this variable that I've created and go to the very end. And here I actually have a row command after the evaluate statement. And if I run this, this will display the actuals end date. And if I run this, let me comment this out. And if I run this, when it works, it says that my range ends on 2/27/2017. And if I come in here and find this last actuals date, that's 2/27/2017. So our logic works. So we can assume that start and end dates work very well. Then we need to figure out which week are we in. So we're going to have, so we said that we're going to create an index. So we have two types of indexes. Number one, index within the actuals dataset. And then when we go past the actuals, we also need to keep incrementing our index for all the subsequent weeks. So let's say I'm in this week. I just need to figure out, based on the beginning of our period, where the actual start, what is the sequential number of this week, right? So if I have 2 years of actuals, and now I'm in week 1 of year 3 as a forecast, it'll be 52 plus 52 will be the actuals, and I'm in week 1, so the index will be 105. 52 plus 52 plus 1 is 105. So that's what this logic here does. It's looking at the selected, it's calculating the selected week variable. And to do this, we're going to look at all of our dates, right? So it's important that we're not looking at the only one day that's selected by being inside of the chart. We're going to look at all of the dates that are less than where we are right now and that are bigger than the start of our period. And then we're just going to count distinct number of week start dates, which is representation for how many weeks we have. So if I want to see what that selected week index is, then I can just run it, and that'll tell me how many weeks I have in my data set. So now I have what my current week index is, and now I can start putting together that data that we need ultimately to calculate our line through. So our table in that case is going to be called weekly data, and the approach is the following. We're going to take our values for all of the week start dates. So this is our seasonality grain week. We're going to add a revenue column to it, and we're going to use this line here to calculate the week index, but now just within this table. So this table will give me the week number, the revenue, and the index of the week in this data set. And then what I do is I just filter out all of the rows that are not blanks. Again, it's very important that in this data set, there's no blanks. Now, we're not going to deal with validation and what to do with blanks. You may want to replace them with zeros. Again, you will have to think about how to deal with blanks. We're assuming that we have a data point for every week in our data set. One thing you would do is, for example, replace revenue with a 0. So you'd have to think about how to handle missing values. So let's take a look at what this calculation does at the end. So let's comment out this, and after we run this, now we see, so basically we're going to get that weekly data, and we're going to sort it by week start date. So that returns back a table that has my week in here, it has my revenue, and it has an index. So now I know for every week what the index is. The reason we need this index is our X, okay? So that's what we're going to be using to do our X in our line calculation. So now once that's done, we're going to be using another cool Power BI function called line. And that function, let's see what that does. So we're going to uncomment this. We're going to comment this. In the final file, you should have most of these already in there, so it's easier for you guys to debug. So when you run this, this creates a table. So this line stx function creates a table, and in this table, what it does, it says, if this were my y and this were my x, what would the line look like to run through this data set? So now for this line, the first column here is slope, and the second column here is intercept. Now we have a bunch of other things in here, and these other columns in here will tell you the quality of this prediction. How well does Power BI feel about the quality of this line? So again, covering the data science portion of this is beyond the scope of this course. For now, all we care about, if you're actually looking at something that has natural seasonality in it, you will find that this normally would be pretty decent. But all we care for now is the slope and the intercept. So then now that we have stats calculated, we just retrieve the first column. Here I'm using max x, or then we retrieve the second column. I'm using a different approach just so you guys can practice as to how you can get these values from this table. And at the end, you will return slope times selected week index times intercept. So here here's the formula for our line. So obviously we're in the DAX query view, so I have this return line commented out. But when you paste the code from the page into your model, then this will be the line expression And then what it does, it uses the selected week index, which we calculated above. So when you add this calculation to the chart, it will read the week, right? It'll convert the selected week index and it'll be able to plot out your forecast, your trend line. So you could see the trend line plotted on this chart right here. And now welcome to lesson 3, building the seasonality measure. Now that we have our trend calculated, we're ready to tackle the seasonality component. So again, just to refresh things, if you go to theory, what we're trying to do is we're trying to take our seasonality, our trend, or our data, our actuals, and break it down into trend and seasonality. So what you can see is the seasonality should look pretty similar year over year. That piece should be very, very similar. And our approach is to add this to trend to get the final forecast number. Our approach to get the seasonality will be simple in this case. You can make it very complicated. There's many different approaches to how you want to calculate seasonality. So you could use moving average method. So there's a bunch of different things you could do. What I'm gonna do in this lab, just to keep it simple, because we're just trying to teach you the foundation, the thinking through how to approach time series forecasting. The way we're gonna do this is we're gonna find like weeks. So for example, this is week 50 and this is week 50. So we're gonna go back through however many years of data we have. We're gonna find week 50 in all of the data sets. We're gonna add them together and then we're gonna average them out. The caveat, however, is that we don't want to average the actual values. We want to deduct our revenue trend from it, because at the end we're adding trend and seasonality. So we want to calculate seasonality that's not impacted by the trend, right? So for example, this would have been much lower or somewhat lower if there was no this trend line running through my data set. So the way we calculate seasonality, we take out this trend and then we compare the like weeks 50 to 50, 45 to 45. We average them out and we're going to use that for seasonality, and you can see that works pretty well. So let's take a look at what we need to get there. So in order to do this, we need to calculate that detrended revenue first. And as you can see, this logic is extremely simple. All we gotta do is take our revenue and we need to deduct sales forecast trend from our revenue. And that's gonna get us the detrended revenue. Once we have the detrended revenue, we're ready to tackle the sales forecast seasonality. So let me flip over to Power BI and let's walk us through this logic. As we see again, seasonality is a shorter calculation. Let me make this a little bit bigger so you guys can see better. But still, we will go through this step by step just to make sure you guys are comfortable with the logic that we use in this calculation. Now, here, this calculation will read your current year and current week from the chart. In our case, in order to test it, I'm just going to hard code a week and a year. So let's say I'm going to be in year 2016 and week 50, and I'm going to try to calculate what would the seasonality value be for this. What's our logic? The logic is very simple. Given where we are right now, let's look back at all of the like weeks in the past, right? So what we're doing is we're gonna say, look at the year that's before the current year, but still look at the same weeks. So that's gonna give me all of those dates, right? And then what we will do is we will summarize these dates based on, for every year and every week. We're gonna add our detrended revenue. I'm just gonna call it sales. Probably should have called it detrended sales. And we're also gonna add original sales, just so that we could filter out the records where there is no original sales, right? So that's gonna give me a pretty nice historical view of our actuals. So let's run this. And now we see what this prior year table, the return table, looks like. So we have two columns here, right? So we have current year and last year. We have 2 weeks, 50 and 50. We have what the detrended values are, and we have our original sales, just so that we can filter out weeks that do not have values populated. Basically, if my date dimension goes back 20 years, but I only have 5 years of actuals, I only have 5 years in this table. And then when I'm done, I could just use this averagex function on prior year, and that will return me return back to me what the average value is. So now I have my trend and I have my seasonality. And now we're ready for the next lesson. Okay, you're in luck. Lesson 4 is nice, sweet, and short. Here, all we need to do is do a little bit more cleanup to prepare for our visualizations. So we need to do two things. We need to create our final measure, which is the sales forecast. Sales forecast is the measure that combines our seasonality with our trend. So ultimately, that's all the work that we had to do was to create this sales forecast measure. And we also create the actualized forecast revenue. So that's the measure that we create purely to make our charts look better. And I will explain why. But basically what we do here is we say, hey, if I have a sales value, use that. If I don't have a sales value, use the forecast measure. So for anything historical, it'll show the actual sales value, and then everything forward-looking, it'll just create the sales forecast. It should take you just a few seconds to create these measures, and when you're done, go ahead and jump in Lesson 5, Visualizations. Hello, and welcome to Lesson 5, Visualizations. So now we get to put our metrics and measures to work and actually see what kind of visualizations we can create. So let's flip over to Power BI Desktop and see what we got. So I'm going to click on my main tab in the desktop. So here's my revenue trend. What I've done is I've added my sales forecast trend and I dropped it below the revenue trend in the y-axis. One of the things that I will point out, if you go into line and format it, you will see that here I'm using this pink color. And the reason I want to highlight it for you is because we're going to test how well our logic works. And the way we're going to test it while we're in this chart, I'm going to go into Power BI Further Analysis tab, and I'm going to click on Trend Line. And we don't know if it's exactly as the logic that we used before, but what I will do is I will just keep bumping up the width until you will see that the line that it generates covers the line that we created. And if I hide this, you will see the hour line from our measure right behind it. So that proves us that the trend line that Power BI wants to run through our dataset is exactly the same one that we created ourselves. So now the advantage is, now that I know have this measure, I can use it in all kinds of calculations. I can talk about things that are growing, things shrinking. So trend is now at the tip of my hands, and I could do all kinds of cool insights based on this calculation. The next step is our forecast. So again, what we do is we take our actualized forecast revenue and we drop it on top of the revenue measure. So if I move it below revenue measure, you see that dotted line. I formatted this forecast measure to be dotted. And you see what it does, actualized, it shows the same as actuals, right? But then for forecast, it shows the forecast value. But why did I need to do this for the actuals? The reason I did this is because if I just started from the forecast, you would see a bit of a gap between the actual and the forecast. It would just not look nice. And sometimes you would start playing games with scale and other things depending on the forecast values. So what you want to do is you want your forecast value to go all the way to the beginning, just so that it looks nice, right? So now you have a very uninterrupted this look and feel of how the data flows, and that's what you want. So I recommend, could you use your sales forecast? Absolutely. If you're trying to build a table, you don't need actualized forecast revenue. You could just use sales forecast measure. But in the trend line like this, bar charts, things of that nature, using this actualized forecasted revenue actually makes a lot of sense. While we're at it and you have the final model available, you can also see how I tested this thing. So for example, you can click on week 50 for 2016. And here I'm saying it's week 50. This is what the revenue is. This is what the trend is. Now we take out trend from the revenue. That gives you my detrended revenue. Then I can calculate my seasonality, which is the difference between detrended this peak and detrended this peak, right? We average them out. And then that's my seasonality. Now if I add seasonality to detrended revenue, I'm going to get my forecast. So you could just use this tab here in the desktop just to test things out, just to get the level of confidence that the numbers are working right. Guess what? We're done and we're ready to wrap up. Congratulations and thank you. I hope you find this course to be very valuable, and I hope you got some good hands-on practical experience and all of the knowledge necessary to build trend and time series forecasting calculation on your own. We thank you for your time and your commitment, and we look forward to seeing you how you can apply these new skills to drive success in your future projects. While you're on our site, feel free to explore additional labs. We're working very hard to add more and more material, and you will see more and more labs and courses available here for free. And also you can check out our IP, our demos. You might find it useful. You might get inspired and use some of the design patterns, some of the visual patterns, some of the ideas that we have in our dashboards. There's plenty of live dashboards sprinkled through our site, and you might find it useful for some of the projects that you're working on. So thank you again for taking this course, and good luck.